So here you see a few different outlets. Let's say this first outlet represents the outlet in one bedroom. This is an outlet in another bedroom farther down the hallway. And maybe this is an outlet somewhere in the bathroom. Maybe all these outlets operate on the same circuit in your house, meaning if one circuit breaker trips but not the others, all three of these outlets go out. Well, how are all these outlets connected together? Are they all in series? Are they all in parallel? Is it a mixture of the two? Let's say that represents the hot wire in AC electricity, and this represents the neutral wire. If I want several outlets, then I can provide a connection. I'll actually put a switch along that connection, and then I'll leave an opening here and here. There we go. I can make as many of these as I want. Okay, so this represents the outlet. There's the short slot on the plug, and there's the long slot. See, so that's the connection to the neutral, and that short slot is the connection to the hot. And then the switch just controls whether or not. Now, you don't always have a switch on these outlets, right? Sometimes you just plug in and there it goes. You don't need to hit any switch on the wall. So, sure, I could just have it like this without the switch, and that represents the outlet sort of turned on its side, right? There's the short slot, there's the longer one. So that's it. How does it look like these are all connected? Yeah, exactly. They're all in parallel. And of course that has to be the case, right? If all the outlets in your home were in series, then that means everything would have to be turned on simultaneously for any one thing to work, right? That's the way a series connection is. It's just like the headlights in your car. We've all seen a car driving down the highway with only one of the headlights on. So that's how we know the headlights on a car are in parallel, not in series with each other. If the headlights were in series, when one of them burns out, even though the other one is still operational, it won't light up, because burning one thing out when the two of them are in series breaks the circuit. Speaking of breaking the circuit, there's very likely on the neutral something like either a fuse or a circuit breaker. If it's a fuse, you might diagram it like this. So if too much current is flowing, then the wire in the fuse burns up, and now the whole circuit is incomplete. There's no complete path, and then nothing will operate until you either replace that fuse or flip the switch on that circuit breaker. In any case, that's just one detail you ought to know about household electricity. We already know it's a source of AC. We know that the peak voltage is 170 volts, but on average, the RMS value is 120 volts, and we know that they're all connected to each other in parallel. Oh, by the way, then we know this shorter slot is the connection to the hot, and this longer slot is the connection to the neutral, and I'm pretty sure you all know that this is a connection to ground. So every single connection to ground is wired to each other. All of these grounds are connected together. Ultimately, one of them goes off and literally is connected, wraps around, typically in the construction of a home, a water pipe, and that water pipe is buried deep underground. And so, that's provides what we call like case grounding on appliances. Now, not all plugs have a connection to this, right? So in cases where there's a large current, like maybe power tools Anything that has a really large current draw on it then typically has a prong that'll plug into this ground, and it helps with something called case grounding, and I'll describe that in another lecture video. Yeah, anyway, in the same way, then all of the hots are basically all connected together, right? So they're all in parallel. Anyway, maybe that's a simpler way to draw it. Yeah, thanks for watching.